Today we're looking at designing and building the X-axis for the CNC router. Each axis of the CNC router is controlled by the length of the ball screw. The ball screw has been purchased to allow us to machine a certain width in the X-axis on the CNC table. Once we've made that purchase, all of the X-axis dimensions are controlled by the constraints of this size of CNC axis. What do I mean by that? Well, the X-axis of the CNC is limited by the width between the bearing housings and the size of the carrier when it butts up against each end of the ball screw housings. The axis supports, in this case, a 2x1 3mm aluminium angle. I'll temporarily clamp one side of the ball screw bearings check that I've left room for the linear rail attachment. Here we see the temporary clamp. This will be the drive side for the stepper motor. The ball screw spindle, the mounting bolts and the linear rail. In this instance, I've put the linear rail just at the top of the angle. The ball screw bearing housing butting up to the linear rail, and this is to maximise the height of the x-axis to give me plenty of use of this angle. So with the ball screw temporarily clamped to one of the x-axis uprights, we've now got a first look at the x-axis uprights. Here we see the newly assembled x-axis mounted on the base chassis of this CNC router. I tried to design it with rigidity and repeatability in mind, so I've used heavier gauge linear rails and ball screws throughout the design. I'll zoom in a little on the parts and then we'll describe them. The top rail is a 16mm linear rail fitted with a single linear rail block or carriage. Sole purpose of this in the design is to offset the torque of the ball screw. For the ball screw to move left to right, i.e. the x-axis on this machine, we need to offset the torque. So attaching the linear rail above it, and I'll join it to the ball screw block. By joining it, we should see stability and rigidity as the ball screw block moves from left to right on the x-axis. I should note at this point all bolts and fixings on the project at present are temporary, cheap and nasty bolts just used to assemble the structure for me to visualize the next part of the process of designing and building. So when the project's nearing completion, all of these cheap and nasty cap screws will be changed for decent quality items. I'll pause the video, attach a pistol drill to the drive end of the x-axis ball screw and give a little demo of it moving along. Okay, we rejoin the video with the linear rail carriage temporarily connected to the ball screw nut by a couple of bolts and a tie wrap. This will give us a good demonstration of the torque reaction in the ball screw carriage during movement along the x-axis. The first thing we'll see when I press the trigger of the pistol drill is the ball screw nut trying to turn on the ball screw. Because it's attached to the linear rail carriage, this torque is offset, and that's why we get movement along that axis. So pressing the trigger of the pistol drill, we move it steadily along. Reversing the drill. That concludes the demonstration of the x-axis. Hope you're enjoying following on the build process, and hope you'll join me as we go along and design and build the Z-axis. Thanks for watching.